Let's now save the folder. To save it, go here, save project. I will save it to desktop, and in course file I will give the file name as P1 step bar with Excel loading. Just note that the extension which answer saves is in .wbpj. It's workbench project journal. So it will save now. So if we'll go to that folder, it has created this file folder and this workbench icon file. So under the file folder we have so many different files and the folder. So what is under this files? To know that, we'll go to the view and we'll click on the files. So here we understands that what is in those folders. It saves the engineering data, design points, and as if you have will create geometry, model and other things, it will say store those data in these files. So whenever I want to share this workbench file, never share this wbpj and this folder alone. Always it is recommended to share in the form of archive. So if you'll archive this, it will save in the form of wbpz. So always share .wbpz files, and wbpz file can be directly open in the answers. We'll close this file view. Let's begin with the providing engineering data to answers. By double clicking on our engineering data cell, the engineering data application will show up in front of us. If you're not able to see this kind of layout, then you can go to views and click on the reset workspace. So this happens when you use a public computer or college computers. So some students might by mistake close some tabs and its layout get disturbed. So left hand side is a toolbox where project material properties are listed. This is a project material list. By default, in a static structural application, Answers Workbench consider structural steel as a default material. Below is a property table of material on which you are right now. So in Answers, basically there are three methods to create a material. First, from scratch. Second, from engineering data source. And third, duplicating and editing material. We are going to make a material using all the three methods in this. Let's see how to add your own material from scratch. We'll start with adding a brass. We now want to specify material property for brass. So we'll go here and we'll type brass. So material is added, but you can see the question mark because no property are added in the property outline. As you know, for a static structure analysis, Answers requires two property to solve mathematical model. First is a Young's modulus and second is a Poisson's ratio. So let's go back to the problem statement and check out the values for the brass. Young's modulus is given as 105 GPa and Poisson's ratio is 0.34. Double click on isotropic elasticity here. It will add the two properties here. Yellow field indicates it requires the inputs. So Young's modulus is 105 gigapascal. Giga is 10⁹, so we'll type E9. Make sure that unit is Pascal here, If it is not, then drop down and select Pascal from the drop down list. And Poisson's ratio 0.34. So the brass is added, question mark has gone out. Now we want to add the aluminum. We are going to use a second method, which is by using engineering data source of ANSYS. ANSYS has its own engineering data source library, and it's here. We'll click on engineering data source. We are having an option of so many engineering data source. We'll go for a general material, and from general material we'll go for fourth cell, which is of aluminum alloy. To add to project, we'll click on this plus symbol. A book symbol will appear. It indicates that this material is added to your project. Now aluminum alloy is added. We'll go back and close the library. Aluminum alloy is added to our project. We'll verify the data for aluminum alloy. We'll click on aluminum alloy, and the library data shows that Young's modulus is 7.1 into 10 to the power 10 Pascal and Poisson's ratio of 0.33. In our problem statement, Young's modulus is given as same 71 GPa and 0.33. So we'll not edit this value. Third way to create material is duplicating and editing. So the last material which we need to add is a steel. So what we are going to do is this default structural steel, I will right click and I will say duplicate. So it will create a structural steel 2. I will rename this as my steel. The steel properties of Young's modulus in database is given as 210 GPa and Poisson's ratio of 0.3. Here the Young's modulus from duplicating structural steel comes out to be 200 gigapascal. So we'll edit this to 2.1 gigapascal. So I will write 210 gigapascal and Poisson's ratio of 0.3. Okay, so we have added all the three material of our project. Now we'll close the engineering data and come back to the project schematic. So out of a 6-step, first step of inputting engineering data is completed. Second step is to create or provide a geometry. So we'll see that in the next video.